Hello everyone. So we are in section 2.5 and I chose a question here that I feel like is a pretty challenging question. It's got some larger numbers, lots of factors, okay? So I'm going to kind of walk you through this. I'm going to talk about kind of the method that I use. There's actually lots of ways to solve these. So this is just going to kind of be how I go through it. So the first thing that I do use is the rational zero theorem. I use that theorem all the time. When we get to Descartes' rule of signs, I actually don't use that one as much. I'm going to go through it to show it to you, but it's not actually something I like. I don't like that one. But regardless, we'll use it so that I can show it to you. So I'm going to write down the function just so we have it. Okay. And this is one of those things, these take up some space, so you don't want to do this when you've only got a little bit of room left on your paper. Okay, so unlike the problem that we did in 2.4? The problem in 2.4 gave us a zero to start with. They were very nice and very helpful, and they said, hey, one of your answers is this. The problems in 2.5 give us nothing. They don't give us anywhere to start. But we have the rational root theorem, or rational zero theorem. And the way that works is we list out P, the factors of the last number, and Q, the factors of the leading coefficient, and then we divide them, and those are going to be our possible roots. Okay, so let's work this out. All right, so Q is actually going to be easier. Factors of 4 are 1, 2, and 4. And they can all be positive or negative. Because it could be 2 times 2, or it could be negative 2 times negative 2. So they're always going to be positive or negative, kind of regardless. Factors of P, that's going to be a much longer list. I'm going to show you a trick in your calculator, okay? If you go like you're gonna graph something, which I mean we're not graphing anything right this second, but if you type the number that you're trying to factor divided by x, and again I don't care about the graph, that's not what I want. I want the table. I'm gonna hit second graph to get the table, and it gives me all the numbers that multiply to get 108. So that's a neat little trick that I like to use when it's a large number and I really don't feel like coming up with that whole list. So I know there's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, right? So I'm going by this table and I'm using all the x values that have a y value that's nice with no decimals. So I'm not going to use 5 because 5 ended up with a decimal there, right? Like that's the idea. Oops. Come on now. Oh, stupid. Okay. So I was at 4. So then 6. This is going to be a long list. Let me pause this. I'm just going to go through the calculator and finish the list. Okay guys, so you can see towards the end there, these numbers get pretty big, and I didn't want to keep fussing through the table until I got to 54. So once I got as high as about 12, I started just dividing by the factors that I knew I already had. So I was dividing by these numbers to get the pair that goes with them, the other number. So 2 times 54 is 108. 3 times 36 is 108. So that's how I finished out this list. So again, I picked this problem because I knew this list was going to be obnoxious. And I'm going to show you kind of some tricks to how to make this go a little easier in the calculator. So those are all my P's. These are my Q's. And what the rational zero theorem says is I need to do P divided by Q. And these will be the possible roots of my polynomial. Okay, we're just trying to work out some possibilities. Okay. The one thing is we have to do every P divided by every Q. So like let's look at P equals 1 right here. I have to do 1 divided by 1, 1 divided by 2, and 1 divided by 4. I have to take every P and divide by every Q. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 4 is 1/4. Then I move to the next P. So 2 divided by 1 is 2. But 2 divided by 2 is just 1 again, and I don't have to list that again. And 2 divided by 4 is 1/2, and I don't have to list that again. So it'll start getting a little easier because they're just going to repeat themselves. 3 divided by 1 is 3. 3 divided by 2 is 3/2. And 3 divided by 4 is 3/4. Okay. 4 divided by 1 is 4. 4 divided by 2 is 2. That's already there. 4 divided by 4 is 1. That's already there. 6 divided by 1 is 6. You get the idea, right? So I'm going to go through and finish this list, and then I'll be right back. Ooh, okay. That was a long list. So this problem really is a little obnoxious, to be honest. But what we've done with this list, what the idea is that we are looking at this problem like we have no idea where to start. The zeros could be any number from -infinity to infinity. And what we've done is we've narrowed it down to this list, where now it's like the zeros can be any number in this list, right? So that's how this is supposed to help. Now, on most problems, this list is a lot shorter. On most problems, you've got it narrowed down to like 4 numbers or 6 numbers. And at that point, you would just go and plug them in, or, you know, try some synthetic division. And you're looking for ones that when you plug them in equals 0, or when you do synthetic division, you get a remainder of 0. But I don't want to sit here and plug in a whole bunch of these. I really don't. This just is, I mean, I would have to go through and I'd be like, okay, it's 4, let's try 1 to make it easy. And then 1 to the 4th minus 18 times 1 to the 3rd plus 42 times 1 squared minus 108 times 1 plus 108. And I hit enter, and that didn't equal 0, so 1 doesn't work. So then I'd go on to the next one, and I'd have to do this a whole bunch of times. And I mean, I can make it easier by hitting things like second and enter, pulls up what I just typed, so then I could just go in and change all the 1s to 2s or something and try the next number. But this is going to take too long. So our next option, right, like that didn't work, so it's not 2. So our next option is Descartes' rule of signs, which really only narrows down whether or not the numbers we are testing should be positive or negative. And honestly, for this problem, it's not even worth going through. If you want a video on that, let me know. I'll do a video on that. But I really don't use Descartes' rule a lot because it doesn't narrow down the list enough to make it worth doing. It doesn't save enough time to make it worth anything. What I do is I graph it. Okay? I cheat. I graph it. It's not cheating, but it's the shortcut. And what we're looking for, since we're looking for zeros, are x-intercepts. We're just looking for where it crosses the x-axis. And we don't even need all of them. We just need one to get us started. We need one spot where it crosses the x-axis. Oh, my window's off from a previous problem. I'm sorry, hold on. So it crosses the x-axis somewhere in between 1 and 2, probably 3/2, but it's hard to tell. But I know it crosses at 3. You guys see how it landed right on 3? So 3 is probably the one I'm going to start with. And then I could probably use 3/2, it looks like. So first I'm going to do synthetic division with 3. Because I can see that 3 should work. So I'm going to do this real quick, and I'm running out of time, so I'm going to pause and skip through that. Okay, so I did synthetic division with 3, and it did work out to have a remainder of 0, but I knew it would because I knew it was one of the zeros here. So now I'm going to try 3/2, because that looks like 3/2 to me, or 1.5. So I'm going to do it again with 3/2, but now I'm going to use the reduced polynomial because this was x to the 4th, so this will be x cubed, but I need to get it down to a quadratic, so I need to do it again. Okay, so now I'm going to do it with 3/2, so I'll be right back. Okay, so the idea being, this had a remainder of 0 also, so 3/2 also works. So far our answers, if I make myself a little list here, our answers include 3 and 3/2. And you'll see they were in our list, but how long was it going to take us to figure out that those were the answers, right? I would have had to go through all these, and that's just a pain. So graphing it saved us time because we could see where it crosses. Now what you got to be careful is that does not mean we're done. Just because it only crosses twice does not mean those are the only 2 answers we're going to have. This is degree 4. I should have 4 answers. So my other answers, because I see it's not crossing anywhere, must be imaginary. That I know. So looking at this, I've reduced it again. This is x squared. I have 0x plus 24. So I have, let me switch colors, 4x squared plus 0x plus 24 equals 0. This is actually pretty easy to solve. We can just get x by itself. Sorry, I have a 15-minute time limit with the video maker that I use, so I'm trying to hurry up so we don't have to do a second video. Divide by 4. What is that? -6? Yeah. So now I've got x squared equals -6. So if I square root both sides, well, okay, so it's x equals plus or minus, because it's a square root, I square root it, I have to do plus or minus. The negative makes it an imaginary number. So it's plus or minus I square root of 6. I can't simplify 6 into something that uses perfect squares. If I could, I would simplify it, but there's no way to simplify that. So we're going to type our answers in over here. We've got 3, comma, 3/2, comma. We have I square root of 6, and we have negative I square root of 6. Okay, and that's going to be it. So yeah, basically, sometimes these are a pain, but if you use your calculator, you can get through it a little faster than doing all of this by hand. All right? You still have to do the synthetic, though, to get down to a quadratic. Let me know if you have questions.